This is just a brief introduction to scientific writing, so a great practice to use when you're writing lab reports or when discussions are looking at scientific data and theories and that sort of thing. So scientific writing, a really good structure to use would be the CRE, Claim Evidence Reasoning method. A claim is a statement that you're making as the author regarding the topic. So this is what you think is happening. This is what you feel it is. And then you're going to use evidence to back that up. And the evidence comes from the data, and so you're showing how the data actually support the claim. And reasoning, you're giving an analysis of the reliability of that data. I talked to an English teacher once who said, yeah, we use that same type of method. Ours is, they call it TEA, thesis, evidence, analysis. So if you've ever used that in English writing, this is the same idea. So the thesis would be your claim, evidence, again, the same. Analysis, reasoning, same thing. So let's look at a sample here. Let's say that you have a lab where you're examining the different variables between gases, the relationships between different variables for gases. And the first one that you examine is the relationship between pressure and volume of a gas at constant temperature. So on the right, you see a graph that was produced from the data collected in the lab. Let's look at how we can go about writing this relationship. So first of all, we're going to make a claim between the pressure, about the relationship between the pressure and volume at a constant temperature. It doesn't need to be anything fancy. In fact, we like concise writing in science, so you can make a very simple statement here. At a constant temperature, the pressure and volume of a gas are inversely proportional. There's your claim. Evidence, you want to make sure that you're demonstrating how you drew that conclusion, made that claim. So here, it might be something along the lines of talking about the shape of the graph, how as the pressure values are decreasing, the volume's increasing, or vice versa. You could get really specific with data points, and you could talk about how at a pressure of 60, the temperature is around 23, but at a pressure of 40, the temperature is around 36, and show that. Reasoning. So here's where you want to talk about the reliability of your data. You're going to relate it to any known value. Are you calculating the acceleration due to gravity on Earth? So how close did you get to 9.8? You can talk about if there's any error that you know of. Let's say you're calculating that value of 9.8 for the acceleration due to gravity, and you get 9.7. Okay, well, we know we're a little bit off from the known value. Why is that? Why do you think that happened? Was there some instrumentation that you knew to be faulty or something of that nature? So in this case, we can look at it and say, well, the data appear to follow Boyle's law, which states that the pressure of a gas is inversely proportional to its volume at a constant temperature. So the experiment appears to have a lot of reliability. And you can see the equation of Boyle's law down there in the bottom right corner. And so here we seem to have some very good reliability within our data, so that helps to strengthen our claim. Now, this is more of a challenge and advanced option at this point, but know that scientific writing really tries to remove the human element. So to do this, all the writing is done in the third person and any reference to humans is removed. So that is like the exact opposite of what you're taught in your English class most of the time. Most of the time in English class, you're taught to use these active verbs and have this really dynamic writing, and science goes the opposite direction, and it uses a passive voice. And this can be really challenging when you first start, but feel free to give it a try and ask your instructor if you want feedback on it or help doing it. So let's say you're going to make a claim and you start to write, I found that the acceleration of the car was, well, let's pull that back. Let's put it in the third person. So then a lot of people would write, the student found that the acceleration of the car was. Well, pull back again, remove the human element. It was found that the acceleration of the car was. So now we've got no humans involved. We're in the third person. And basically what we're doing is we're allowing the data to do the speaking. Okay? It's no longer you did it, I did it, we did it. It's the data shows us. The data show that this happened. So let's just recap your CRE, your claim evidence reasoning really quickly. So easiest way to look at this for your classes, if you're doing a lab and you've got your post-lab write-up and there's a question it asks and you answer that question, you're making a claim. Okay? However you answer the question, you're making the claim. Back that claim up with data. That's your evidence, okay? And that data that you're backing it up with is from your lab. Then you're going to want to give some analysis to that data. How reliable is it, okay? Does it align with the theory that's being examined? And what about the information you're learning in class? How reliable do the data appear to each other? So you're looking at the standard deviation. What are possible sources of error that cause any variations in the data? Why is it not lining up with the theory? Why is there such a large standard deviation? So these are some really good practices to start putting into use for writing labs.